Welcome to Tutor-E's Chemistry Hub. Here we'll do our very best to make chemistry as simple as it can be. We are running to the end, gradually, of stoichiometry. We've dealt with the various types. Now we are looking at limiting reagents and excess reagents. And that's what comes with this first question. We have dealt with the question in previous videos. However, in those cases, we are giving mass. In other cases, we are giving volume. In this case, we are dealing with volume of a liquid, which obviously will come with concentration. And once again, you always remember, once you are dealing with that, your important formula becomes concentration equals the number of moles divided by the volume. So in this case, all we are asked to is to determine which is excess and which is limiting. So let's go ahead. Again, the very first thing is always remember, you have to get your equation of reaction. So we are told aluminum nitrate is reacting with sodium hydroxide. This is a clear case of double decomposition reaction. And what does that mean? The compounds involved will simply exchange their radicals. That means NO3 goes to sodium and aluminum takes up the hydroxide. However, you need to remember to write their chemical formulas properly. For example, aluminum hydroxide, you are going to be writing it as Al OH3. If you write the wrong formula, then what you're going to calculate is most likely going to be wrong. Check out my previous videos on how we get the formula of compounds using their oxidation number. Alright, and then sodium nitrate is simply sodium nitrate, NaNO3. So the next step is to balance our chemical equation. Again, check out the videos on how we balance chemical equation and you get a proper idea. However, in this case, this is what we are going to have. If you check it out, one atom of aluminum on both sides, nitrate is 3 over here, nitrate is 3 over here, sodium is 3, sodium is 3. Then if you observe, hydroxide is appearing as hydroxide on both sides, so we'll take it as 1. So we have 3 hydroxide here, and we have 3 hydroxide radicals in this product side. Once again, check out the video on how to balance chemical reactions, and you should be good with this. So as usual, if you are looking for what is excess and what is limiting, we are dealing with both reactants. So we simply have Al NO3 as what we are dealing with, and we have sodium hydroxide, 3 moles of it. Again, you remember, since you are dealing with concentration of liquids and the volume, we just easily solve with number of moles. So we just need their number of moles. For aluminum nitrate, it is just 1 over here, and for sodium hydroxide, it is 3 moles. So the next thing is, from the question we are given, we extract their number of moles. And because we are given the concentration and the volume, the number of moles equals concentration times volume. So for aluminum nitrate, the concentration is given to us as 0.1. So our number of moles equals 0.1. You can see it's not written as mole per dm cube, it's just written as molar. That's another way of writing the unit of concentration, just capital letter M. 0.1 times the volume, which is 30 cm cube. However, you need to remember your volume has to always be in decimeter cube, and that's the reason why we divide by 1000. So when you do this, 30 divided by 1000 should give us 0.03, and then 0.03 times 0.1 should give us 0.003 moles. You can confirm that using your calculator. So that's for aluminum nitrate. Next, we get for sodium hydroxide. Moles is mol. Sodium hydroxide, again, same thing applies. Number of moles equals concentration times volume. So the number of moles equals, we are given the concentration as 0.15 times the volume, which is 100. Again, remember it has to be in decimeter cube. So you multiply by 1000. So the number of moles, 100 divided by 1000 is 0.1 times 0.15 should give us 0.015 moles. So that's simply how we get that. Up next, remember, since we are dealing with the concept of limiting reagents, we behave as if we don't have the information of one of them and use the other one to calculate. And then we simply ask ourselves, what we got, is it more than what was given or is it less? If it is more, that means it is excess. If it is less, that means it is limiting. All right, so I'm going to assume we don't know the number of moles of sodium hydroxide. So we simply ask ourselves, if 1 reacts with 3, then 0.003 is supposed to react with how many moles? We cross multiply, and we have that x times 1, which is x, equals 3 times 0.003. So that means we have 0.009 moles. So that means that 0.003 moles of aluminum nitrate should actually react with 0.009 moles. However, how much are we giving? We are giving 0.015. And if you observe carefully, you see that 0.015 is greater than 0.09. You can simply compare it. 0.015, 0.009. When comparing decimals, compare the whole number. If they are equal, then move to the decimal part, each of them. 0 equal, 0 equal, 1 0. 1 is greater than 0. So 0.015 is greater. So what does that mean? We needed only 0.09 moles of sodium hydroxide, but according to the question, we were given 0.015 moles of sodium hydroxide. That means we have more than what we need. So therefore, let's simply put it here, that sodium hydroxide is excess. By what amount? It is 0.015 minus 0.009. And if you subtract that, you should be having 0.006 moles. So sodium hydroxide is excess by 0.006 moles. That's simply how it is done. So now, that leads us to the next question. In this case, we want to determine the mass of calcium carbonate that will be precipitated. Again, observe, we are given information about both reactants. That means, what do we do first? We determine the limiting reagent. And you remember, it is the limiting reagent that determines the amount of product. So once again, our equation of reaction, sodium carbonate is reacting with calcium chloride. Sodium carbonate reacts, not produces. Reacts with calcium chloride. Again, this is going to be a case of double decomposition. They simply swap the radicals that they carry. So sodium takes chlorine and calcium takes carbonate. So you have CaCO3 plus NaCl. Once again, you have to write the chemical formulas properly. Up next, check if our equation is balanced. It is not. Simply place a 2 here. And now our equation is balanced. So what are we dealing with? First, we need to determine the limiting reagents. We are given information about both of them. So we are going to be dealing with sodium carbonate and calcium chloride. We are given concentration and volume, so we just need to deal with the number of moles. Here it is 1 mole to 1 mole. I think this is the easiest. If the mole ratio is 1, then they should react in equal amounts. Alright, so let us get the number of moles that's given. For sodium carbonate, again, remember, number of moles equals concentration times volume. So the number of moles equals the concentration, 0.2 times the volume, which is 50, again, has to be in decimeter cube. We divide by 1000. So the number of moles equals 50 times 0.2 should give us 10. 10 divided by 1000 should give us 0.01. Let me confirm. Yeah, that's correct. And then for calcium chloride, to get the number of moles, the concentration, we are given as 0.15 times the volume, which is 75 divided by 1000. It has to be in decimeter cube or liters, whichever one you prefer to call it. And when you do that, you have 0.01125. So if you check this out, remember they are reacting 1 to 1. So therefore, they should always have equal amounts. So technically, if you don't want to calculate this, you simply know that sodium carbonate should be your limiting reagent. But once again, let us test it out. We behave as if we don't know one of them in order to test our limiting reagent. So we don't know the value of calcium carbonate. So we just say if 1 mole reacts with 1 mole, the question now is 0.01 mole of sodium carbonate should be reacted with what amount? X times 1 gives us X equals 0.01 times 1 gives us 0.01. So that means we actually require 0.01 mole of calcium chloride. But how much was given? We are given 0.0125. Again, you can always compare 0.01125, 0.01. Since one has more decimal places, you simply add 0, 0, 0 to fill it up. So compare 0 to 0, 0 to 0 equal, 1 to 1 equal, but 1 to 0. So this is larger. So that means that we needed 0.01, but we are given 0.01125. So therefore, calcium chloride is the excess reagent. So we can simply say sodium carbonate is our limiting, you can say reagent or reactant. And we have that. So what do we do next? We now remember the limiting reagent determines the amount of products. That simply means that in this case, sodium carbonate, our limiting reagent, will determine how much calcium carbonate is produced. Again, the mole ratio is 1 to 1. And then how many moles of sodium carbonate was used up or was given because it's limiting. That means it must be exhausted. It was 0.01. 0.01, we produce how much of calcium carbonate. And when you cross multiply, you simply have that X times 1 is X equals 0.01 times 1. We have 0.01 moles of calcium carbonate. So that means that the number of moles of calcium carbonate that will be produced is 0.01. But remember, the question said find the mass, not the number of moles. Remember the next formula? Mass equals the number of moles times the molar mass. If you don't want to waste time, the molar mass of calcium carbonate is 100. Calcium is 40, carbon is 12, oxygen, the atomic mass is 16 times 3, that is 48. When you add them up together, 12 plus 48 is 60, 60 plus 40 is 100. So the molar mass of calcium carbonate is 100. So therefore our mass equals the number of moles, which is 0.01, times the molar mass of calcium carbonate, which is 100. If you multiply, the mass equals 1 gram. And that is how you solve questions that involves limiting reagents. Determine the limiting reagent, and it is that limiting reagent, its quantity, that you use to determine the amount of products. That is stoichiometry. Remember to solve more questions. If you have issues, drop them in the comment below, and I will definitely do my very best to make a video solving those same questions. In the meantime, like, share, and subscribe.